The second application of pointers is in dynamic memory allocation. So if we declare an array of integers like this, we're limiting our program to handle a maximum of 10 numbers. Now, what if we run the program and we get more than 10 numbers from the user or as part of reading a file? Well, we can increase the size of this array to 100 or 1000 or even more, but again, there is always a limit. Now, what if we receive only a single value from the user? Then we have wasted a lot of space just to store a single value. This is where dynamic memory allocation helps. So instead of committing to a high number like 1000 initially, we can allocate space for storing, let's say 10 numbers. Then during our program execution or at runtime, if we need more space, we can allocate it on demand. This is dynamic memory allocation. Now to allocate memory dynamically, we're going to use a different syntax. We cannot use this syntax to declare variables. So to do that, we're going to use the new operator followed by the target type, which is an integer array. Now here in square brackets, we specify the initial size, let's say 10. Now this returns an integer pointer, so we store it in a variable called numbers. Now I'm going to comment this out so our code gets compiled. Now when we declare a variable using this syntax, that variable is declared in a part of memory called heap or free store. In contrast, with the first syntax, that variable is declared on a different part of memory called the stack. Now, the great thing about variables declared on the stack is that they get automatic cleanup. So once they go out of scope, the memory that was allocated to them gets released automatically. In this case, you know that the scope of this variable is limited to this function. So once this function finishes execution, our numbers variable is going to go out of scope and the memory that was allocated to it will get released automatically, so it can be reused in the future. Now in contrast, when we declare a variable on the heap using the new operator, we programmers are responsible for the cleanup. And that means if we don't do our job properly, the memory that was allocated for these variables will never get released, and our program will end up consuming more and more memory, and eventually it's going to crash. We say our program is having a memory leak, meaning it's constantly consuming more and more memory. So once we're finished with this variable, then we should always deallocate memory using the delete operator. Now here we're dealing with an array, so we should type square brackets followed by the name of our pointer, numbers. Now here's another example. We can also use the new operator to allocate a single integer on the heap, and just like before, this returns an integer pointer, so we store it in a variable called number. Now, technically, there's really no reason we ever want to do this because it's much easier to declare an integer on the stack, and with this, we don't have to worry about cleanup. But later in the course, we'll talk about creating complex structures, and you will see that using this technique, we can store a complex structure like a movie or an order or a customer on the heap. So here we declare a variable of type integer on the heap. We do some work with it, and just like before, when we are done, we should always deallocate memory using the delete operator. Now here, because we have a single integer, we don't type square brackets, we just type the name of our variable, okay? Now, while not mandatory, it's always a good practice to reset these pointers. So I'm going to set number to null pointer and do the same with numbers. Okay, so this was the basics of dynamic memory allocation using the new and delete operators. In the next lesson, I'm going to show you how to dynamically resize an array.